So I was going to start out talking about LinkedIn and the Economic Graph Challenge, which is something that we recently won and have been participating in, but it's very early on. I'll talk about kind of interesting issues with LinkedIn data. I'll talk about our team and proposal, a little bit about general challenges in analyzing like really big data, including big network data. And then I'll actually want to present some results, and also these analyzing big networks is very related to neuroscience problems, and so I'll kind of wrap up with an application to brain structural networks and creativity. Okay, so LinkedIn, just a show of hands, who's actually like a LinkedIn member, which doesn't really involve anything, it just means you have sort of a profile and you're connected to people. So you know the basic stick is that there's actually hundreds of millions of people on LinkedIn, and it's a really interesting data set. It's a sort of high-tech company, approximately 8,000 employees. They get over $1 billion in annual revenue. I think they work a lot on trying to connect employees and employers, and so that's their sort of game in some sense. And so their focus is the goal of the company is on creating economic opportunity for all 3 billion people in the global workforce. And so they're trying to get essentially everybody in the world to have a basic profile on LinkedIn. Of course, they won't ever realize that, but getting something close to that. And so they're getting, actually, every year they get massively more members, massively more connections. And so the data are really pretty interesting, I'd say, in terms of the general computational social science problems. And so you can really address incredibly interesting things based on the data. You know, one example, I'll go into some more detail, but one example would be like, well, let's see how Duke or Duke Engineering does in terms of preparing people for the workforce, students for the workforce. And so you could actually go into the massive LinkedIn database, look at all the people who graduated from Duke in engineering, follow them over time, look at their career progression, and look at them compared to people who graduated in Stanford in engineering. And so you can actually look at these types of progressions, and the companies can look at these types of progressions to actually come up with targeted rankings of universities and different programs. And so that's just one example. There's many examples of what you can do. You can even predict the number of creations of new jobs more accurately, I think, than the Bureau of Labor Statistics does. Yeah, so there's hundreds of millions of users already on LinkedIn. It's a really interesting data set. So what type of data do we have on these users?
How do you get access to all this data? Do you have to pay LinkedIn to get access to it, or is it free? Or?
Yeah, that's a really great question. So the idea of this Economic Graph Challenge, which I'll talk about, is that they created this challenge. And so in the past, the LinkedIn data was only accessible to LinkedIn employees. And so they're very concerned about privacy considerations and data getting out based on various incidents there's been in Facebook, et cetera. And so they are really worried about providing access to the data, but the data are really interesting. And so they've decided to have this challenge where they had people submit proposals to get access to the data and also access to LinkedIn resources. And they ended up selecting 10 teams, of which ours was one. And so then we have access to a LinkedIn employee and pretty much the entire data set to work on whatever we're interested in, really, but sort of targeted towards our proposal. And so the idea is hopefully this is we're kind of guinea pigs, and then hopefully that works out well, and then they'll have some sort of process for releasing more of the data, maybe not all of the individual data, but more of the data. And so I think this will definitely be an ongoing thing, that people can submit proposals anyway to get access to the data. Any other questions? Okay, so what type of data do we have? Well, there's sort of user interest, educational background, employment history, endorsements, and connections with other users are sort of like some of the main pieces of the data. And I originally got into LinkedIn, you know, I got an account just to help my students get jobs, essentially. And so a lot of my students go on to kind of high-tech industry jobs, and they actually, it helps them get jobs if you're connected to them, and then you're also connected to other people who are doing well in the industry. And so that's why I got on initially. And so, yeah, that's a lot of what it is. Okay. But then over time, you probably, if you're on LinkedIn, you get some of these annoying emails where they'll ask you to endorse people for different things. And so they'll actually use those endorsements companies will to try to identify employees that are really good in certain things, you know. So, but they'll weight the endorsements by the quality of the endorser. And so I might be endorsed for machine learning, and so if I've been endorsed very many times for machine learning by really good people in machine learning that were also endorsed very many times, then that gives me a high endorsement score, and then I might be recruited by some company looking for somebody who's really good at machine learning. Okay, so it's sort of like a Facebook for business networking instead of social networking. And it's sort of amazing to me that they can make as much money as they do, given their sort of business model. But a large focus is on connecting employers and employees. And so there's many, I talked to them a little bit, and so I think that the most lucrative part of it is trying to attract really, really highly skilled workers, in particular like high-tech domains, for example. So there's somebody who's really great, and having that person might really impact how your business goes, you know, coming up with very innovative ideas for making lots of money. You know, for example, one of my friends who's now at LinkedIn, he did one change, and that one change that he did that he came up with made the company $150 million a year. And so if they didn't have this guy, Deepak Agarwal, then maybe the other person they hired might have not come up with that, and then they would have made massively less revenue. And so these little changes actually on the scale of what they're doing can make a really big difference. And so the companies are really, really interested in getting these really top people like Deepak. And so Deepak is happy, you know, he was happy at Yahoo before, and but they can identify these people really good like that and then start recruiting them. And then probably, you know, he's willing to have the conversation, you give him more salary, you give him more management position, etc., access to more interesting data, and then you can, you know, potentially recruit them, and they did end up recruiting them to LinkedIn. That's just one example, but the companies will actually pay a lot of money to get access to these really highly skilled workers. They're actually not looking for jobs and won't apply for jobs. Yeah, so that's that point. And so they charge a fee for these things. They also charge a fee for some networking. So if I wanted to contact somebody to establish I can send what's called an in-mail to them. I might be a younger student and want to establish some sort of network connection, ask them about some internship or something, but they're not in my network, then I can pay for that. Okay, so what do LinkedIn employees do? They employ individuals who are really highly talented at data engineering, I call it, computer science. And so there's increasing workforce of jobs like this in Google and IBM Research and LinkedIn and Microsoft, and there's a lot of jobs out there for kind of data engineers. You know, people who are really adept at dealing with enormous data sets. And I think that, you know, one comment I have is that the skills that we get at Duke, for example, but at most universities, don't really prepare you to deal with these data sets. And we ran into that in this collaboration. You're used to, like, you know, a data set, you download it on your computer, and you read it into some program, and you do some sort of, you know, analysis of that data set. But that's completely impossible for data to scale. And so they actually gave us a dedicated network of 120 computers, and then you need to do things completely differently using different types of coding. You know, you might have to code in Java through Hadoop or these different software called TIG in order to, you know, you have to distribute all of the operations and store the data on different computers entirely in order to do anything. And so I think actually Duke does a pretty poor job of training people to do that currently. And usually people will learn how to do that, you know, when doing a summer internship or initially when they get to the company, which is sort of what we're doing right now, you know, trying to get our team able to do these things. Okay, so it's really complicated to mine the really enormous LinkedIn database to maximize the user experience, and the data are so huge. I mean, you have hundreds of millions of people, and then you can think about, well, the connections, all possible connections among hundreds of millions of people is just absolutely absurdly huge. And so you can't even do simple things. Simple exploratory descriptive analyses of those data are really hard to do. You have to think carefully to do that. And so you might want to do something like there's a whole team, a bunch of employees that are trying to select good potential connections to users. And so if you log into LinkedIn, it'll often like well, maybe you'd like to connect to these people, And so the simplest algorithm might be based on just, the number of, that's another person who shares a lot of your current connections. But they'd like to do something more complicated than that as well. How to best recommend potential employment opportunities. That's something that, in my observation, they're not nearly as good at least they're very poor in my case. I'm sort of an academic. And so they'll suggest these kind of jobs I would never be interested in. But I think for other people, like if I was their target audience, which is maybe some super highly skilled employee in some high-tech industry, I think then I would be getting very reasonable employment ads. And so, okay, so one of the other interesting questions is how to maximize the quality of the network and limit data corruption. And so there's a tendency, it's like, great, we have this huge social network, business network data, which they call an economic graph, but what does that have any quality to it? Well, some people will connect with everyone. Like if somebody sends me a connection request, if I don't know who they are, I just turn it down, but a lot of people will just connect with everyone. And so there was some guy, I guess, who was connected with 100,000 people. And so it creates a lot of problems. So one problem is if the network isn't sufficiently sparse, you can't really do analyses very efficiently on it. And the other problem is it's just useless information. It's just corrupted by these giant nodes contaminating the network. And so they've done various things to try to limit that problem. Now, when you connect with someone, you have to say how do you know that person, for example? Okay, so the economic graph. And so this sort of economic graph vision is to have a digital mapping of the entire global economy. And so you have a profile of some information on conceptually all 3 billion members of the global workforce. You have some professional identity of them, and you would like to be able to help them find and realize their most valuable economic opportunities. And they're really interested in expanding this. Now it's obviously very biased towards more highly educated people, more affluent types, but they'd like to expand it much beyond that to more working class type jobs. And they've made some sizable steps in the last year to do that. Okay, so they'd also like a profile for every company in the world, who those companies and the products and services those companies offer. Okay, so you can imagine if you had that data, you could do some really amazing things with it, even if it wasn't quite to this ideal of everyone, it was just a large selection. Okay, so they have these different aspects, these 6 different key aspects in LinkedIn. There's skills, members, jobs, companies, knowledge, and schools. And so you'd like to sort of have a pretty sizable, close to complete representation of all these different players. Okay, so I said these things basically. So what's the economic graph challenge? And so the challenge was posed was, given the wealth of data that exists within LinkedIn, what research would you propose that has the potential to create greater economic opportunity? So they put this challenge out there, and they have there's a $25,000 prize, and then you get access to the data, and you get access to a dedicated LinkedIn employee that can do your analyses for you, and you have a laptop that can connect to their network, etc. Okay, so it's pretty cool when you start thinking about the data. We just were at this initial LinkedIn workshop for the winners of the challenge, and it was pretty amazing what the other people came up with. You can really address a lot of really cool things based on the data. And another comment is that there's otherwise lack of access to very large network data. And so that creates difficulties for academics in trying to develop methods for dealing with large networks. One of the main data sources that people use is Twitter, but I would say, to me anyway, LinkedIn data is a lot more interesting than Twitter data, things that people tweet, who cares? It's sort of, is there any interesting information in there? I don't know. But whereas this economic data, relating education you have to jobs, etc., and what people are linked to who, there was even a really interesting team from Harvard and MIT that had a group of all women, and they were using the data set to look at kind of the good old boy system and the lack of economic opportunities for women in high-tech industry, for example. so that's one example, and so I said these things already, and so there was, I guess, something like 300 to 500 proposals, and they were going to select one, but and I said what they would receive already, but they instead selected 11, and they just had this opening event that we went to at LinkedIn in Mountain View, California. And so the exciting thing to me, one thing was that it was pretty cool. Like, you would think that Stanford and MIT and Harvard and stuff would dominate it, but actually Duke had the most individuals among the winners, narrowly beating out MIT. And so we had 2 winning teams, and there was a 3rd individual from Fuqua who was in one of the other teams. And so Duke had a really sizable presence also among the employees at LinkedIn, which was surprising to me. So I think that Duke is actually kind of really taking off in terms of the big data analytics kind of field overall, and this is one symptom of that, I think. So our team was really, I'd say Yan Sheng was the intellectual leader of our team. It was her idea to go after it, and the basic idea was hers. And so she's a PhD student in the Fuqua School of Business. She's a really brilliant student. Also, Joe Fatoma, who's another student of mine in statistics. He has a really big data interest and background in computer science, and so he's been really useful as well. We're also really key, I think, to us pulling this off is that we have somebody on the inside who is Larry Karen's student, who's phenomenal, who's actually working at LinkedIn now. And so he can actually help us pull this off, because the data are so huge, and we want to do scalable inferences on this huge network. We don't really have the background. We can write down something academically to do that, but actually implementing it on their platform is virtually impossible without some inside insight. So I said that already. And so what was our idea? So we wanted to use the LinkedIn database to build a roadmap for the virtual professional world. And so what I view this as is, I remember, like, I didn't know what I wanted to do. I was an artist in high school. I was pretty good at math. And so I ended up going through 5 or 6 different majors. So I went to Penn State, and I didn't really know. I like started in I think engineering for a couple weeks. It's too boring, and so I switched to geophysics, and then I switched to biology, and I was going to go to med school, and I ended up in mathematics. And so I think that if you had a tool, I'm like, what could I do to figure out what people actually do in the particular job? You have no idea as a student. You're a 17, 18, 19-year-old student. You don't really know what people do and how to get there. We had this blue book. You'd go through the different majors, and like, I don't know what a geophysicist really does. But so what I'd really like is like a tool, so like a Duke undergraduate or a high school student could say, well, I'd like to be somebody like Guillermo Shapiro, or I'd like to be somebody like working in this hedge fund or something. And so how do I get there? What are the paths by which I can get there? And so how do I maximize my chances? Are there particular schools? Are there particular people I need to network with to maximize my chances of getting those types of jobs? And so that's sort of our vision. And so it's definitely in modern business, getting ahead and getting the desired career goal, having the desired skill set is really increasingly complex. And you really can't just have it in your head and just sort of stumbling along is maybe not the best way to do it. And so I'll give an example. This is sort of like for my son. You know, he's just turned 18, but he's interested in car design, engineering, sort of green industry appeals to him, and he thinks Teslas are really cool. You know, incidentally, Yan's husband works at Tesla. But and so we'd like to. What if you wanted to work at Tesla in some capacity, and you're a 17, 18-year-old? How do you achieve that? Well, you can imagine. Well, taking the big database, looking at people at Tesla, like exemplars, and saying, well, what do these people look like? And now I've clustered a bunch of people look like them, I've clustered a bunch of people look like me. Or is there a path that I can travel? And then as I travel along that path, can I adapt the path? Because maybe I didn't get into Duke, I'm going to NC State or something, and so now maybe it's a little harder for me, but I can do something else. So that's the sort of thing we want to do. And that just sort of got that across. And so just if I'm running out of time, just tell me to shut up at any point. So also, I think that it's really, the sort of connections part is really crucial. Not just like you go to some school or something. Like, I think getting a job in this high-tech industry is really, really depending on connections. Like if you go to grad school, for example, who you work with, who your advisor is crucial. Like maybe Ying Gan got the job at LinkedIn because he worked with Larry Karen, who's very famous in machine learning, and had a lot of connections to LinkedIn, for example. Maybe because I wrote him a reference letter. You know, maybe because he did an internship. He did an internship at LinkedIn, and that went really well. And so there's sort of the connections that you have to establish in order to get these positions. And so how do you do that? Maybe it's a key internship. Maybe there's a pipeline from particular schools that you go to. Yeah?
Do you have proof of that?
Proof of what?
That connections lead to an outcome.
Well, it's sort of obvious, but you could test that on the data set, certainly.
Why do you say so?
Well, I mean, I think that...
Let me go on. There's a theory in recruiting, and there's a theory in job hunting. Network, connect. But I don't know that that's true. I don't know that it's proven. Is there evidence to that effect?
I mean, I don't know about the literature on networks leading to jobs, but I think it's definitely true in my own experience academically. Among my students, I've had probably 30, 40 students and postdocs, and certainly if the people where they're going, whether it's academic or industry, know me and I have a connection there, it's definitely more likely that they're going to be hired. They're like, oh, it's a Dunson student, we know what that is, you know, and so. I would be surprised if you could take, that's one thing you could do on this database. That's one thing that they wanted to do, this group of women wanted to do is see how that works, you know. Why are there so few women hired in the high-tech industry? It's abysmal. Is it some connection problem? And so I think that would be an interesting thing to look at through the data set.
I think it would too, because I think a lot of people accept that as a fact, but I don't know that it's necessarily proven.
And I think that's one aspect of our proposal. We'd like to, so the one perspective is from an employee, the other is from an employer. And so, like, let's say you're LinkedIn or some high-tech company, Google, maybe you have a pipeline from Stanford or something. And so there's too much of this connection going on, and so maybe you don't want to hire the employees that are heavily connected to you because you're not looking broadly enough, and maybe those employees are more heavily sought after and there's more competition among them, and maybe there's some people over here who are just as highly skilled, maybe even more talented. And so that was what people have gotten really excited about, for example, these online education. There's some kid, some girl in the Middle East, she doesn't have many opportunities, she takes this online course and she beats all the Stanford grad students, and now people want to hire her. And so that makes a way to get away from, you know, having to be stuck in this kind of good old boy system network thing. And so hopefully some of this technology and data allows us to get away from that.
Same question about endorsements. You had mentioned earlier that you get these annoying emails from LinkedIn about endorsements, and they are incredibly annoying. But I don't know that they're a predictor of success, if you will.
I mean, they think they are a predictor of success. I would agree. Like we almost think it's a joke. Like my wife endorsed me for babysitting. You know. So I have an endorsement for trail running, babysitting, and oil painting. Like on the bottom below my machine learning and Bayesian statistics and all that stuff. And so, but they try to get away from that sort of thing by trying to see weight the endorsements by who's endorsing you. So they believe, anyway, that they contain valuable information. But I think it is definitely an open question how much information is actually included in this profile, including the endorsements. Because, you know, they were, I was talking to the CEO when we were out there, and he was interested in our proposal partly because they had this previous thing called the career profiler or something, which they would really like to get something like that to work. But it was it failed terribly. Because what they were trying to do was try to take some kid and then predict what their job's going to be, which is, of course, just ridiculously impossible. And that did very, very poorly. But part of the reason it did poorly might have been the quality of the information on the LinkedIn profile. That's definitely true. And so that's an interesting aspect, is how much information do we really have? That's good. I mean, I don't know, with the time. Okay. Okay, so I mentioned the other side of the equation with the employees. And so let me just talk a little bit about modeling network data, and I'd love to just flash up anyway the creativity and brain network stuff because it's super cool. And so our goal is really to improve insights on how individuals and companies navigate this professional world. And I'm also, I'm an academic. I'd super like to build tools for big data analytics and that we could use on this platform. And that's one of the main things that the people I've talked to at LinkedIn, the more technical people I know are interested in, is we'd like to be able to do what's called Bayesian statistics, scalable Bayesian statistics, which allows for uncertainty, and have a platform for doing that using like parallelized MCMC algorithms. And so they're really, really interested in having that on there so they could use it for all sorts of things other than what we're interested in. And so, so that's one of our main interests. And so, but in this setting, we'd like to build sort of latent trajectory models. So if we have a big network, what we mean by virtual is that, well, every person, we can actually put them in a virtual space, a latent space, and that's one way to build a network model, a statistical model, a probability model for networks is like, well, Ingrid is located in the local latent space somewhere, and I'm located somewhere. If we're close together in the latent space, we might be more likely to have a link between us. But then your latent trajectory model is you're moving across this latent space over time in a sort of a targeted way. Okay, and so, but there's way too much data, and I've said this already, is that I think one thing is that it's really crucial, I think, for Duke and other universities to invest in modern computing and have these modern clusters and have the students play with those modern clusters and be taught how to play with those. Because otherwise, you're kind of stepping into this industry and you're like, I don't know how to do anything. I have to like spend all my time like reading data onto my one machine and running things in the old way, and that's in R or MATLAB or something, and then like nobody actually does that in these industrial settings. So you're doing something completely different. And so, so we need to get people used to that, and that be also true in sciences, like looking at the connection structure of the brain instead of large human interaction networks. And so I'm just going to throw up a couple slides since I'm out of time. Guillermo Shapiro is really one of the kind of world leaders in this area of sort of imaging brain connections. And so what we're interested in the brain setting is instead of interactions among people, we'd like to look at interactions among different regions of the brain structurally. And so you get these, based on modern imaging, you get something like this. So there's all these fibers connecting different regions of the brain, and we'd like to see how that relates to a cognitive trait. And so we're putting in we have a project with the Army right now where a soldier can come in, have his brain scanned, and the idea was, well, maybe then we can tell whether they're better at leadership, or they're better at creative thinking, or they're better at something else. And so, yeah, and so you have data like this. So this is a brain just broken up, for simplicity, into 70 regions. This is the right hemisphere of the brain, the left hemisphere of the brain, and I put an edge. If there's a connection between this region and this region, then I put a line between them. And so we have a data set on low and high creative reasoning individuals. And so this is a lower creative reasoning individual, and this would be a higher creative reasoning individual. And we have lots of data like this. And so each data point is like a network, one of these networks. And we'd like to see how that network relates to something like creativity or some other trait. Okay? And so this just shows some variability. And so we have this brain networks of different individuals, and so you can see how this relates. You could imagine, well, there's like a link between different people, but in the brain. Okay, and so we'd like to learn the generative process underlying these brain network data. We'd like to see how the brain network distribution varies with levels of a trait like creativity, and we'd like to do that formally in a testing framework. Okay, and so the methodology we need is sort of inference on random variables defined on the space of networks. Okay, so I'm just going to skip over this, the details, and we initially used our method. We had a Bayesian model for doing this on scan, rescan data, and so you take the same individual and you scan them twice, and then you want to see if the brain structure's similar enough at the adjacent times so that you can cluster them. And so that turned out to be true, and so we could perfectly cluster them. And we could see how individuals' different brains are deviating. This is interesting. You can actually look at inferences on the complexity of the brain, how that related to different variables. And so here's the complexity. So this curve should drop off very, very fast if there's low complexity. Like if it was like this, it would be a very low complexity brain. And this shows complexity by gender. And so there was absolutely no difference between males and females in the complexity of their brain structure. Whereas we found that there was differences, lower or higher aged individuals had more variability than medium-aged individuals. They had more complex brain structures. Okay, and so then we looked at looking at differences with creativity. And so I'm out of time, but I'll just say the simulation study did incredibly well. And so we did a simulation study to look at performance relative to what people do now. And essentially what people do now is to take the brain and ignore the network structure and then take all the edges and throw them in independent tests and then look at differences with creativity. And then the errors of that are huge. It does terrible. And so if you actually put in more of the network structure into your model, you gain a ridiculous amount of power while reducing the type 1 error rates. And so to just wrap up, I'll just show the results on creativity and brain structure. So there's an ongoing debate on the sources of creativity in the human brain. And so we applied our model in the setting. We'd like to apply a similar model to this LinkedIn data. And we got that there was a hugely significant difference in brain structure between low and high creative individuals. And the differences were attributable to more cross-hemisphere connections in the frontal lobe of the brain. And this sort of shows that. Here's the right hemisphere and the left hemisphere, and here's the frontal lobe. And so that was a very kind of nice new result, and we'd like to take these types of models, scale them up to these kind of economic graph type problems in solving these LinkedIn problems. And so I'll stop there.
I know you've just gotten started on the LinkedIn work, but I'm curious, will that data and what you find out be publicly shareable, or will it only be for LinkedIn?
We'll definitely publish articles on that. The data we can't share publicly, and so I think that's one of the ways that the data are going to be able to be accessible. So we actually have a special high security laptop, and so we underwent this training where you log on to the server. The password changes. You have to pen the password with. I have a little device that spits out numbers, and I have to type in that number, and then the number changes every minute, and the number sequence is unique to me. And so, if you don't have that, if I lost my number sequence, I wouldn't be able to get on there. And then it's sort of all set up so I can't download any data onto my computer. I'm running everything remotely, and so this is really kind of the wave of the future, also in biomedical research with high confidentiality data sets. You can't take the data, I can't put it on my laptop and walk around, somebody might steal my laptop, etc. And so, so I think that we won't ever actually look at the raw data ourselves directly. We have somebody at LinkedIn who can do that and can run on the full data set. But we'll publish papers, but it becomes very different doing kind of data analyses because you can't just take the data and look at the data. The data are too big. You can't access them directly, and so it's pretty interesting to try to do things differently in this kind of modern era.
I had a question about anonymity in large data sets like this. There's been some amount of research on that, like particularly in mobility data, that even when you take a large data set like this and you strip out what we think of as being personal identifiers, and then you aggregate that data. For example, like all the data from people working at a particular company and say, okay, what's the common trajectory that people get to working at that company? That when you really look at that data, you can actually go back and identify those people, even though there's no recognizable identifiers. Have you thought any about that, or what those implications might be for these sorts of projects?
Yeah, I mean, that's really interesting. We have thought about that. Jerry Ryder actually works a lot on that. He's a professor in statistics at Duke, and we have a joint project. And it's definitely true. Like, there's been some big examples of that. Actually, one example is interesting from the work Ingrid and I did. It's a little different, but the museum doesn't like to give high quality images of the paintings because they could publish books on that and stuff, and so they thought they could solve that by removing a checkerboard. But then Ingrid's really smart at image processing, and so she could actually in-paint the checkerboard, and then you have the painting looks just like a completely high-res image of the original painting. And so they thought they were like making it anonymous in some sense, but they're not. And so there's been tons of examples like that in the data confidentiality literature where they think doing simple things makes it anonymous, but it super doesn't. And so that's an ongoing area of research. What Jerry does is actually, if you have a realistic model of the data, you can actually generate synthetic data that look like the real data, but none of the people in that synthetic data set are the people in the original data set. And so that maintains the confidentiality. Otherwise, there's almost nothing you can release from the LinkedIn data that is interesting to analyze that really maintains confidentiality. Like, how many people working at a particular company got a degree from a particular university, a particular area, on a particular date? You know, not many often. And so you end up being able to find who these people are. To me, I don't know why people are so paranoid. I could care less, super care less. Like, there's no information that's actually confidential on LinkedIn. To me, I mean, it's just, oh, it's like where I went to school, what I'm interested in, like people I'm connected with. Who cares if people know that information? But they're very paranoid about it.
This is kind of just a random question about LinkedIn, but I'm sure they have all this data, but since their inception and growth over time, have there been any correlations with actual employment numbers in the U.S.?
I think that's it's sort of the age period cohort problem. I mean, it's like impossible to pull it apart. It's like, but it's super interesting though. It's like, does LinkedIn actually, as a company, have an impact on the employment numbers? I think yeah, I'm not sure. They probably looked at that a little bit because there has been like a really rapid increase in LinkedIn. Like I guess a year ago they had 300 million jobs on LinkedIn, and this year I think it's like 3.5 billion jobs or something. I don't know the exact numbers, but it's some like huge shift because they're kind of cheating a bit as they're scraping jobs from like Craigslist and stuff, but they still they have that access, and so and it might be there's this sort of number of jobs, but then there's also this sort of the quality of the work being done because the people are masked better to the job, and so that's another question because I think a lot of what they make money on is like moving people around between different high-tech companies.
And going to the brain scan stuff you had at the end, has that creativity been cross-linked with other factors, such as, genetics or environmental things that, like bilingual people or stuff like that?
Yeah, that's really interesting. I mean, so we have some of that data. I have a collaboration with Paul Thompson, this group at University of Southern California, and so that we have this this sort of imaging genomics thing is a really big area, and so we're working on that. But it's super early on right now, and so we have some results for Alzheimer's disease, where we do the same thing for Alzheimer's disease, and there's very significant Alzheimer's versus normal aging. And you can also relate that variability to genetic factors, but we haven't done it for creativity. But we have other things other than creativity. We have IQ and creativity and various other kind of personality traits, etc.
That's interesting because it almost relates back to the LinkedIn thing. If you can figure out what feeds into creativity, that helps employers know what factors to look for.
Yeah, I mean, that's one thing we're interested in. I mean, that's the sort of devious thing we're interested in. I'd also like to understand sort of, what causes people to have mental health problems, and can we understand that better? But, the Army project we have is very much like that. Like, you take a bunch of soldiers, and then maybe we can put them in more appropriate jobs based on their brain structure.
I don't see further questions, so let's thank our speakers.